Okay, in this video we are going to be going over some calculator assumed questions. This is going to be a trigonometry question first. So we're asked to find the smallest possible length of this side, AB, in the triangle shown below. So what it means by smallest possible length is that we're going to be getting two length values. The reason why will be shown below. So what we need, we can't assume that this is a right angled triangle. Need to just assume it's not telling us that it's just like an ordinary triangle. So since we're given an angle and a side, and just by the structure of this triangle, we would be needing to use the sine rule to find an unknown angle. So we can use the sine rule to find this angle, little b, which we can then say is sine of b over the length of the opposite side, 62.2, is equal to the sine of this angle, 33.8, over the length, 38.8. We can then rearrange this equation to find b. Sine of b is then equal to 62.2 over 38.8 sine of 33.8. You could just put this into your class pad and solve for b in like one swift step, but I'm just doing it this way because I don't have a class pad. Therefore, we get this here, b is equal to the inverse sine of this number here. So we can calculate this. Inverse sine of 60.2 over 38.8 times sine of 33.8. This gives us 63.1. Now what we can see is that for this equation here, this is a positive value because this quotient, this fraction is positive, sure. And sine of 33.8, if we look at our sine graph, something like this, right? This is at 90 degrees. No, sorry, this is at 90 degrees. You can see that it's positive all the way up to 180 degrees, so sine of 33.8 is therefore going to be positive. Since we know that the sine is positive for this angle, we can say that one solution will give us this angle, but we'll also have another solution here, this one, theta 2, theta 1, where theta 2 is going to be 180 minus theta 1, which we found as being this value here. So therefore our second value is going to be 63.1, 116.9. Now, I think that if you do a class pattern solve, it will automatically spit out the two values that you need. Maybe I'll just write this as B2 and B1. So yeah, it can spit it out, but this is just like an easy way to see, like you have the alternate angle, the reciprocal angle. Now we need to use this information to find this angle C, because with this angle C we can find this side here. So by triangles we know that all of the angles add up to 180, so we can say that C1, the first angle, is going to be 180 minus 33.8 minus 63.1. 180 minus 33.8 minus 63.1. This gives us first possibility 83.1. C2 is now going to be the same thing, except we're replacing 63.1 with B2, 116.9. This would then give us 29.3. I guess the beauty of calculator assumed is that when I calculate it, I could just go up and then just edit the equation rather than typing it all out again. So now we've got these two possible values and we need to find the smallest possible length of AB. Now since we've got the opposing angle of this side, we can then use sine rule again to find the length of AB, which we can state that AB on sine of C is equal to, let's just use the one that we have before, 38.8 over sine of 33.8. This is equivalent to this guy up here. I've just flipped both fractions upside down, so I've done operations on both sides of the equal sign, meaning that it's all good. We can then rearrange this to get that AB is equal to sine of C over this number here, sine of 33.8. Now we know that this is positive because we saw before that sine of 33.8 is positive. And sine of C, well, it's either going to be this angle or this angle. You could just plug both into your calculator and whichever one is the lowest value will be your answer for this question. Or we can use some logic. We know that the sine curve, again, looks something like this, right? Where this point is at 90 and then this is at 180. So we know that this sine graph is going to be increasing, right? Therefore, for a lower value of AB, we need a smaller angle, right? Because 83.1 is going to be something like here, 29.3 is something like here. So that's the difference here. So if we want a smaller value for AB, we need the smaller sine value. So therefore, we need to use this angle 29.3. Therefore, AB smaller is going to be sine of 29.3, 38.8 over sine 33.8. This will then be sine 29.3 times, sine 29.3 times 38.8 over sine 33.8. This then gives us a side length of 34.1 centimeters. Here I'm just doing it to 1 decimal place because the numbers given are in 1 decimal place and I'm remembering the units. So yeah, that was a 3-mark question, but it took me about 9 minutes or something. That's just because I was explaining it, and you can just go through it like computer and just calculate both sides, and then whichever's smaller is smaller, but I'm just sort of giving the reason as to why that is the case. Okay, with this question here, the line AC, the angle AB is equal to 35 and the length OB. Okay, we have AC is equal to 30. So that's this length here. It's 30 centimeters. The area of the triangle ODC is twice that of triangle OB. Determine the length OA. So we need to find this length here. Just by basic geometry, we know that this angle is also 35 degrees because they're alternate angles. Okay, I think we have to use this formula here. That area is equal to 1/2 AB sine of C. The reason why, I guess, is because the area of the triangle is going to be, if that's A and this is H, it's going to be 1/2 AH. But if this angle is that and we have the hypotenuse, then we can say that sine 35 is equal to opposite over hypotenuse, h over 26. Therefore, h is equal to 26 sine 35, which gives us that area is equal to 1/2 of A times B times sine C. That makes that. I guess that's just sort of why we use this formula. So what we can say, we can use this important information here, which says that the area of triangle ODC is twice that of triangle OAB. That means that the area of ODC is equal to 1/2 of the area of OAB. Right? Because the area of triangle ODC is twice that, so you can say 2A of ODC is equal to A of OAB. They're the exact same thing. I'm just gonna use the second one because I think it'll be easier. So we can say 2 times the area of ODC is 1/2 times this length, 14, times this length OA with the angle sine 35. This is going to be equal to the area of OAB, which sorry, this is OAB. So this is going to be 2 times the area of ODC. If the area ODC is twice that of triangle OAB. No, I've written this wrong. This should be the area of ODC. Area of ODC is equal to 2 times area of OAB. That's what we need to do, 2A. So this is area of OAB times this by 2. This will be equal to the area of ODC. The area of ODC is 1/2 of 26 of OC sine of 35. Since this is an equality, we can cancel out this common multiple of sine 35, and this just becomes 1. Therefore, we've got 14 of OA is equal to 1/2 times 26 OC. 1/2 of 26 is 13 OC. And we also have this condition here, the AC length equals 30. We also have OA plus OC is equal to 30. Therefore, we've got a set of simultaneous linear equations. Here, we can say that, we need to find OA. So we can say that OC is 30 minus OA from the second equation. And then we can put this into our first equation, which gives 14 of OA is equal to 13 of 30 minus OA. This gives 14 OA. 13 times 30 is 390 minus 13 of OA. Therefore, OA or 14 OA plus 13 OA is going to be 27 OA is equal to 390. Dividing both sides by 27 will then give us 14.4 recurring. So let's do 14.4 or just 14 centimeters because the question is in 2 decimal places. Or I guess you could do 14.4 because this is part B of question and the highest degree of precision is 1 decimal place. I hope that makes sense.